I'm going to go over the process that you need to be using as you work on all of your homework problems related to categorical syllogisms going forward. So you want to pay really careful attention to what I do here, how I do it, and take good notes. All right, so we have a categorical syllogism that says, some politicians are not truthful people. All politicians are people with power. Therefore, some people with power are not truthful people. Now, the very first thing I need to do, and it's a super important step, is I want to represent this argument symbolically. That means I'm going to assign my terms individual letters to represent them, and then I'm going to rewrite the argument using those letters. I chose P to represent politicians, T to represent truthful people, and O to represent people with power. And that renders the argument, some P are not T, all P are O, some O are not T. Now, I know that rewriting the argument symbolically and identifying your letters with your terms can seem like busy work, but this is going to be a super important step for you to be following as we move forward and things get more complicated. It will greatly reduce the number of errors that you make, and it'll also make your work easier. One of the things that this does, it allows us to verify that our categorical syllogism has just 3 terms, not 4 or 5, or not just 2. The other thing that allows us to do pretty easily is to verify that each one of our terms is a plural noun or noun phrase. Another thing that this allows us to do is to ensure that the argument is expressed in standard form. That means that our major term, the predicate of the conclusion, appears somewhere up here in the first premise. And the minor term, the subject of the conclusion, appears somewhere here in the second premise. And our middle term appears in both premises, but not the conclusion. I can also now very easily verify that my argument contains 3 terms that appear 2 times each in the exact same way. And that's going to be one of the more important things we're going to be checking as we move forward. All right, so now I'm ready to represent this argument in a Venn diagram. I'm going to mark just the premise statements. So I'll start with the first premise. Why not? Some P are not T. So I'm going to go over here to my P circle. And what I want to do is I want to mark one X. And I want to mark that X in an area of my P circle, the green building here, that will show a P that is not a T. So I have to mark a P somewhere in this circle that's outside of the blue circle, somewhere in the green circle that's outside the blue circle. So maybe I mark that X here in area 1. If I put an X there, that says there's at least one P right here. That one X says some P are not T, because it's not in the blue circle. But I could just as easily have marked an X in area 2, because even though that X in area 2 is in the O circle, it's also in the P circle and not in the T circle. So that X in area 2 also says some P are not T. So again, I'm reminded, oh yeah, it doesn't matter the order that I mark the premises unless one of the premises is a particular statement. In that case, I have to start with the universal premise. Okay? In this case, that's all P or O. So I'm going to come over here to my P circle, and I want to turn out the lights in any area of my P circle that's outside the O circle, because I'm trying to show that all the P that exist, they're also O's. So that means there couldn't be any P's in area 1, because any P's in area 1s would be P's that aren't O's, and I'm trying to show that all the P's are O's. So I know I'm going to be shading area 1, but I'm also going to be shading area 4. Because anything in area 4 would also be a P that's not an O. So I turn out the lights in areas 1 and 4, and now I can see that all the P's that exist are here in areas 2 and in area 3. All right, so now what I'm going to do is come back up to my first premise, some P are not T, and there's only 2 areas where any P can be. And that's in areas 2 and 3. And if I want to show that some P are not T, I'm not going to mark an X here in area 3, because that would be a P that is a T. That would show some P are T, and I want to show some P are not T. So now I'm going to mark my X in area 2, and I'm done marking. And so I take a step back, and I ask myself, do I see the conclusion statement, some O are not T, reflected in this diagram? And the answer is yes. This X that's in area 2, that's a P. It's also an O, and it's an O that's not a T. It's outside this blue building. So I see the conclusion statement reflected in my Venn diagram after just marking the premise statements. And that tells me that when I assume these premise statements are true and I mark my Venn diagram as such, the conclusion also has to be true. And that tells me this argument is valid. But my work's not done yet, because going forward, we're always going to be checking our work by using at least one additional method for determining an argument's validity or invalidity. And right now, you have only one other method available to you, and that is to look at the argument's form. Again, this is where reducing the argument down to symbols makes my work much easier, because I can verify that the argument's in standard form, and then I can look to see what the mood and figure of this argument is. And I can see here I've got an O premise, an A premise, and an O conclusion, and my middle term is over here in the subject positions of both premises. That tells me this is an OAO in figure 3. Now I can go to my handy-dandy inventory of valid forms and see if in the figure 3 column the mood OAO appears, and look at that, it does. So now I can be really certain that the work I did with my Venn diagram was correct, and that this argument is valid. And I've verified that by checking it with another method. And that's what we want to make sure we're doing going forward.